Hello and welcome to this webinar on getting started with FieldPlanner and GVERSE Planner. Today we will be talking about using FieldPlanner utility within GeoGraphix. We'll be going through some of the basic workflows such as creating well pads and field plans within FieldPlanner, and we will also be going through some of the newly added features such as generating fishbone multilateral plans within FieldPlanner. Then we'll be moving on towards GVERSE Planner, and we'll be discussing about using the GVERSE Planner module in two different modes, the field planning mode and the standalone mode. So we'll be going through some various workflows such as adding and moving new and existing target points, exporting the well trajectory data, generating Geoprognosis reports, and in the GVERSE Planner standalone mode, we'll be talking about the as-well planning methods, how to generate multi-kickoff trajectories, and adding target points directly from GeoAtlas maps. So we'll begin with the field planning module, and for that I'm going to go ahead and launch the GeoAtlas window. Okay, so here in the GeoAtlas window I have a saved map opened up, and for the field planner utility to work effectively it is actually necessary for a saved map to be opened up within GeoAtlas. So you can either open an existing map or you can create one on the go and then save it. Either way, it is important that you do have a well-based layer and at least one ISO map layer added to your saved map. Once you have that sorted, you can go ahead and create your well pad and launch the field planner module. So a little about the field planner module here. The field planner in general, it allows you to add or create well pads. It allows you to determine the number of wells in each well pad and also to determine their location and their orientation on the map and in the plan, of course. So we're going to go ahead and get started with the well pad, and we're going to create a new well pad here. If you see in the main map view, I have one well pad already created. I'm going to zoom in to the area of interest, and we're going to create a similar well plan, sort of a replication of the workflow. Now, there are a couple of ways in which we can create well pads within GeoGraphix. One would be to go to the Wells tab here and then click on Add New Well Pad to Database. Over here, we can assign the pad name and type the parcel value and elevation value. If you have specific coordinates, you can enter them manually here. If you do not, you can actually hover your cursor over to the location where you'd like the plan to be. You can see the coordinates changing here. And once you're sure this is where I want my plan to be located, you can left click on there to lock the coordinates. And once back, we can fill in the length value and the width value and the azimuth angle. Once you're happy with the well pad, you can click on Create Well Pad and then close. Now, this well pad, it gets saved as an entity on your active well base layer. So that would be one more thing, that when you are creating the well pad, it is necessary that you do have a well base layer set as an active layer. Once you have that, we can now go ahead and launch Field Planner from the Launch Field Planner icon in the GeoAtlas Pro toolbar. Okay, as the FieldPlanner launches, we can see that the window, it has a couple of options here that we're going to discuss shortly. But first we're going to go ahead and click on this little icon over here, which is a prompt for creating a new field plan. Right here we can give our field plan a new name. Okay, so we've got the field plan created, and you can see as the plan is created, we've got two options for well pads available, one that I had created earlier and one that we just created here together. We also have two other options. So you can also create new well pad using the new pad option within FieldPlanner, or you can just create an auto pad, which will take you directly to the GeoAtlas map window, and you can, with the help of a cursor, you can choose the exact point where you want your pad to be, and the values will be populated here in the pad properties window. So I am going to choose the pad 2 option here, the one that we just created. And we've got the elevation and the size from length and width fields already filled. Okay, so on to the right, we have the slot configuration table. Now over here, you can select the layout format, number of slots you're going to add to your field plan. So I would like to have one slide in my field plan and 3 slots per slide. You can go ahead and add that azimuth, change that azimuth angle as well. Over here for slot location, we give 2 options. So the select slot location is the more interactive one, which will again take you to the GeoAtlas window, and you'll be able to interactively select slot locations on the map itself. Or again, if you have specific coordinates, you can override that and you can enter your coordinates here. I'm going to go ahead with the select slot locations option. Now, since I have 3 slots, I'm just going to select the first and the location for the last slot, and the program will calculate the rest. So you can see if we go back to the GVERSE planner window, the GVERSE field planner window, we've got these fields filled in automatically. Now there are some other fields that we will need to fill in to configure our field plan. So in the lateral field, you can add the well spacing, the step out length, the kickoff depth, the heel to toe length, and so on and so forth. So for your well spacing, I'm going to keep it to 200. This can be okay. And the surface that I am selecting, the target surface will be the surface that will be selected from your isomap layer. So I'll be choosing the RDRV subsea surface for this purpose. Once you're happy with your configuration here, you can go ahead and create the pad and click on Update Pad. So as you click on the Update Pad button, the pad will automatically be generated in GeoAtlas. Okay, so we can zoom out a little to look at that pad. Okay, so you can see that there is also this one field plan layer that has been created and added to your layers toolbar on the left, the layer selection bar. So this actually is an Esri layer, and it can be exported out of GeoGraphix as well. And using this option, you can go to the layer display attributes toolbar and change a lot of different things, your well stick color and weightage and so on and so forth. We're going to keep it like this for a while, and we're going to come back and change this once we have generated the deviation surveys for this one in GVERSE Planner later in this workflow. Now, going back to the GVERSE FieldPlanner window, we can see that we have 3 new wells created over here. Now, these are sort of preliminary wells in a way that they are not saved to your database yet. This functionality is actually very effective when, say, you're planning a lot of wells, and at that point, if you're not sure whether you'd like to confirm this field plan or not, and so once you're sure, you can save them to the database. This will prevent any unnecessary clutter within your GeoGraphix database and will also save a lot of time for you then. So one of the biggest advantages of the Field Planner module at this point is that it allows you to generate the field plans automatically instead of having to draw them by hand on the GeoAtlas map. This is efficient in a way that the module is simple, and it also allows you to interactively edit several parameters, including the layout, number of slots, kickoff depth, heel to toe length, and so on and so forth. So along those lines, now that we have this field plan saved, we're going to work on another feature within the Field Planner that has recently been introduced in version 2022.2, and that is the fishbone planner. Now, the fishbone planner, it is used for the multi-lateral well configuration, so you can create the main bore and the side tracks automatically. Again, this is better instead of drawing by hand. So for the field planner, again, we will first go ahead with creating a new field plan. We can just name it as retro field plan and click OK. Now we can go ahead and right click in the fishbone wells section. We can go ahead and right click and select add main bore to add a main bore. We can assign the main bore a name. Let's say main bore 2. You've got several parameters over here, and we're going to start with the lateral parameters. So the first thing in the main bore parameters would be the main bore heel points, the X and Y points of the main bore heel points. So if you have specific points, you can add them here, or you can select from the map. I'm going to go ahead and select from the map itself. Once you have the point selected, you can go ahead and open up your GVERSE Planner window again. And as you can see, the heel point X and heel point Y fields have already been populated. You can now go ahead and assign a heel to toe length for your main bore here and a main bore azimuth angle. So I'm going to give it 1800. My azimuth angle will be, let's make it 70. Okay. Now, in the sidetrack parameters, we have a couple of fields here. And most of these fields, although these are configurations for all of the sidetrack nodes, but the parameters that we are putting in are going to be the parameters for the first sidetrack node, and then all the other nodes would really just be a replication of the first sidetrack node. So they will be created at this interval that you can define in the offset field. So moving to the offset from main bore heel, this would be the offset distance for the first sidetrack node. Then the angle for the first sidetrack node, and the length. Okay, for the inflection point, which is the inflection angle of the first sidetrack node, we can make it 140. And for the lateral length, which is the length from the inflection point till the borehole point, we can make it about 180. Okay. The next box is sidetrack planning method. Now, if you choose in both directions, you'll get your sidetracks in both directions. Then you get two options. So you either have create the given number of sidetracks from heel to toe, in which you can assign the number of sidetracks over here, or you can go ahead and create sidetracks at the given interval from heel to toe, and you can assign the sidetrack interval here. We're going to stick with the first option and assign 12 sidetracks for the number of sidetracks. And then in the next box, we have the target surface options. Just like the last field plan, we're going to choose the retroverse subsay. And once we're happy with our values, we're going to go ahead and create the main bore. You can click on the update main bore option here. And through similar process, it's going to, as you can see, you have these sidetrack wells being populated in the fishbone wells section. And as we go to GeoAtlas, we can see our fishbone plan has been created. Now, there are a couple of ways in which we can edit this plan over here. We can edit there are some things that we can edit, and then there are some things that we cannot edit. So the main bore, heel, and toe, they cannot be edited. But the sidetrack starting point, the inflection point, and the borehole, the bottom hole, these can be edited. So to edit the sidetracks, let's zoom in to our fishbone plan a little. Okay. So to edit the sidetracks, you can click on a single sidetrack like so, and right click to activate the move points window. Over here, you can give it an offset value. So if you give a positive offset value, the sidetrack would move towards the toe. And if you give a negative offset value, then the sidetrack would move towards the heel. So let's say I want it to move 10 meters towards the toe. And there it is. Now, you can also edit multiple sidetracks at a time. So you can click Control on your keyboard and keep on selecting those sidetracks. And I can deselect this one. Okay. And I can prompt again, right click, and I want all of these to move 10 meters towards the toe. And there we are. So you can also move your entire fishbone plan itself as well. So if you click on the plan, the main bore, the bottom hole, or anywhere, you can select the entire plan. And when you right click on it, the configuration options window appears. So you have a couple of options here. You can try to rotate it. Let's say I want to rotate it 60 degrees. So it would look something like that. I'll bring it back towards its initial configuration. So I'll just highlight it and right click, rotate, and since I did rotate configuration 60 degrees, I'll just revert that. Okay. One more thing that we can do is we can click to highlight the fishbone plan, and we can create a copy of it too. So we can move it to a certain position. In that sense, we can move it too. So you can choose the move option here and click OK, and it will be moved to a new location. If you want to create a copy of your fishbone plan, again, you will highlight it and move it to your desired position. And once the dialog box appears, this time you can choose the duplicate option and click OK. And there you have your duplicate. So if you want, you can change the orientation of this duplicate. You can flip it vertically. We're going to flip it back. And if you wish, you can also flip it horizontally, like so. So you can zoom out a bit to have a look at those fishbone plans. So these are some of the ways in which you can edit and configure your fishbone plan within GeoAtlas, and all the changes that you make within GeoAtlas will be reflected back in FieldPlanner too. So for example, right now we just created a new fishbone plan by creating a duplicate. So if we go back to our FieldPlanner, we can see that there is another main bore created automatically with its own list of side tracks. So at this point, if you want to go ahead and delete any of the main bores, you can do that right here. Let's say that we want to go ahead and delete main bore, the second one, the duplicate that we created. So we can right click on it and select remove main bore. Main bore is removed from FieldPlanner, and again, the change will be reflected within GeoAtlas as well. So that is the fishbone planner mode within GVERSE FieldPlanner. You can further edit your fishbone, the color configurations and everything by going to the layer distribute layer display attributes option here. So if we expand the red river field plan tree over here, expand the fishbone layer tree, so you can see you've got the main ball stick. You can go to advanced rendering and change the line weightage and color at this point. And it will be visible on the map. We can do the same for the side tracks as well. here. Okay, I click OK. So we've color customized our fishbone plan. And that's one of the many things that we can do using the layer display attributes option within GeoAtlas. So that would be it about the fishbone plan. Next, we are going to move on to talk a little bit about GVERSE Planner and how we can integrate GVERSE Field Planner with the Field Planner plan and plan our wells and create deviation surveys and geoprognosis reports. So for that, I would like to move back to the Field Planner core mode and activate one of the previous field plans. All right, once we have the field, okay, we've got the field plan loaded. So if you notice, we've got these yellow icons next to the well symbols in these field plans. These icons signify that these wells over here, they are saved to the database. So once you're sure that you want your wells to be saved to the database, you can click on your well, right click, and select over here. Instead of the update in database option, you'll have a save to database option. So once you click that, your well will be saved to database like that, and you'll be able to view it within WellBase. Now, from here onwards, we'll be working in GVERSE Planner, so we can launch GVERSE Planner directly from within GVERSE Field Planner by clicking on this icon right here. And as you can see, as the GVERSE Planner window opens, it has already read the active field plan and has populated its window with the information it has pulled up from the Field Planner module. So the GVERSE Planner in general, it would allow you to plan wells within Field Planner. It would allow you to digitize the target points and calculate the surveys. It will allow you to display the planned wells in 3D and also to export the well trajectory data into very simple Excel spreadsheets. You will also be able to generate the geoprognosis reports and so on and so forth. So there are different modes to the GVERSE Field Planner. Currently we are using this in the field planning mode. And as you can see, that the workflow in GVERSE Field Planner is a very simple one that goes from left to right. So we've got the Edit tab here, and here you can edit any information. Let's expand our pad 1 and activate and select a well from the left pane. So as I select a well, you can see that the Edit tab is populated with the information pulled out from Field Planner. Now, these tabs over here, the surface, kickoff values, and target 1, target 2 values, you can edit them by clicking on these green edit icons over here. So if you have specific information, the exact information, you can go ahead and edit that and enter it manually. Or you can also do that visually using the Calculate tab right here. So in the Calculate tab, you must be seeing a couple of points. So the first point over here is the surface point, then we have the kickoff point, the landing point, and the bottom hole point. We also have a target point, an extra target point added over here. Just talk about that shortly. Okay, so I just picked up that extra target point and moved it to a different location. As soon as I moved it to a different location, the line, which was previously green, it turned to red, which shows that now this part of the well trajectory is actually not drillable. So how is GeoGraphix, or how does the GVERSE planner determine that? This information is coming from these approach dogleg severity and lateral dogleg severity settings right down here in the settings box. Now again, if you do have this information, the exact info, you can go ahead and override the defaults and edit it over here. Or you can go ahead and simply manually shift your target points until your line turns green, and also until your well trajectory conforms to your target depth or the target surface. Right now, over here, if we exaggerate this a little, we are seeing two different surfaces. So we have the SNMN and the RDRV. Both of these surfaces are the surfaces that are activated and added to my GeoAtlas map right here. So I can zoom into our field plan area. And if we look at the layer selection toolbar right here, we've got the SNMN and the RDRV surfaces. You can add as many surfaces as you want here, and all of those surfaces would then be displayed here in the vertical section box in your Calculate tab. So we're going to go ahead and zoom out. All right. Okay, one more thing that we can do over here is if you wish to add more target points, you can click on this digitize button, the plus symbol on the top right, and add your target point where you see fit. Once you've added the point, you can move it around, and let's say if you want to remove it, if you do not like it, you can simply right click on the point and select delete. So towards our right, we have the plan view, and this is how the well will appear in the field plan itself. If you move on to the next tab, which is the 3D view tab, you will be able to view your borehole in the 3D view. So this is just a preliminary 3D view which is designed to give you an idea of how the well would appear, basically. The next tab on the right is the survey tab. So you see we already have the survey generated over here. And this survey, it can be exported into a very simple Excel spreadsheet format, and it's going to export the survey points, the target points, as well as their respective locations along with the report. So if you click on export and give your file a name, RDRV one, say, you can go ahead and open the report up in Excel, and this is how the report will be exported out. Close out of it. The next tab that we have, the last one, is the GeoProgs tab. Now, the Geoprognosis tab will remain blank until you save your planned well to the database from FieldPlanner. So this, again, the golden icon, it is a proof that your well has been saved to the database. So that's why we are able to view the geoprognosis report for this particular well over here. Now, these are the reports that are given to the drillers to drill the well. So they will contain the header, the mud, and the drilling information. And the most critical information that these reports would contain would be the estimated formation tops. Now, these would be the points where the wellbore would intersect each formation in its path. And so for each formation in its path, the GeoProg report would generate an MD, an elevation, a TVD, an easting and northing. Now, if you say we've got three surfaces here, actually two, the SNMN and the Red River subsea. And this is because, again, I have these surfaces added to our GeoAtlas layer selection toolbar over here. So again, as the more surfaces that you have added over here, all the and any surfaces that you have added over here, they will automatically become a part of your geoprognosis report and will be added to the list of estimated formation tops. So the geoprognosis report that you will export will again, it's going to be in the form of a simple Excel spreadsheet. It's going to contain the header data pulled in from FieldPlanner and WellBase, and it's going to contain the well target locations. So these are the locations where the target points are located. Then it's going to contain the estimated formation tops, which are the locations where the borehole path intersects with the isomap surface in your GeoAtlas layer. So we can do the same for other wells as well. So if we go to well 2 and can quickly have a look at the calculate tab, the GeoProgs reports, you can, for all of the formations here, you can select the formation from the drop-down menu and then select Save to Database to save your geoprognosis to the database. You can click OK. I'm going to do the same for third well. So if we export the report, this is how it's going to look like. Okay, something how it's going to look like. So now that we have gone ahead and created the GeoProg report for our wells as well, the next thing that we can discuss a little bit about is to go to the GeoAtlas window. So we've got our active well plan here, and just like we interactively configured and changed the target points within GVERSE Planner, we can change the location of the target points within GeoAtlas as well. And since GeoAtlas is highly integrated with GVERSE Planner, it the changes would be reflected accordingly. So to do so, first of all, we need to make sure that our active field plan is also set as the active layer and that we have the cursor from the Pro toolbar selected. Once we have that, we can go ahead and select the relevant target point and move it to our desired location. And it will change its trajectory. Now again, if you see the line, it has changed its color. If we go back to GeoVerse FieldPlanner, we do see that this line is being shown as a red line over here. And again, this is because the way we've moved it, this part of the curve is not drillable. So we can try to move it back to position. And the line changes color again. One more thing that we can do with this point is also we can move the entire well plan itself as well. We can pick it up and we can move it just like we did with the fishbone plan. So I'm going to go ahead and select the Red River target surface plan, the one that we created earlier, as the active plan, and I'll go ahead and choose the cursor from the Pro toolbar. And as I click on the well pad, you see the entire well plan, it gets highlighted. So I'm going to hold down my left mouse button and click on the pad to move it to another location. Now, just like the fishbone plan, I've got a couple of options here. I can move entire pad and wells, or I can choose to move just the pad and surface locations only. I can also choose to duplicate the pad, and I can also choose to rotate the pad and flip it horizontally or vertically. Right now, I just want to go ahead and move it, the entire pad and the wells, so I'm going to click OK. And the entire pad is moved to a different location. So in general, this entire process is very much interactive. You can go ahead, you can move your field plans around, you can edit the target points within GeoAtlas or within GVERSE Planner, and all the modules, the GVERSE Planner, Field Planner, and GeoAtlas. They are very efficiently integrated with each other and the GeoGraphix database. So this makes your well planning much more easier and of course automated, right? And that is definitely much better and much more efficient than simply hand drawing your contours, your field plans. Okay, so that would be it about using Field Planner and GVERSE Planner in field planning mode. The next part of this webinar is going to focus on using GVERSE Planner in standalone mode. So we're going to close out of GeoAtlas. We can go ahead and save this base map. Okay, so to use GVERSE Planner in standalone mode, we can simply launch it directly from Project Explorer with no field plan active. I'm going to activate the global AOI first. It's not a necessity. Okay, so as you see, when we launch GVERSE Planner directly from Project Explorer, we get a new tab. So we can use this tab to carry out a lot of operations. We're going to start off by adding wells first. We can also create new well plans and import drilled and proposed surveys. So to add wells, we're going to go ahead and create on the Add Wells button, and then choose your well. Once you've chosen your well, you'd want to create your well plan, and your Edit tab will become active. Now you'll notice we've got one additional field for the Edit tab. This data is being brought in from Wellbase, by the way, right? So we've got one additional field within the Edit tab, and that's the well type field. So over here, for this existing well, we can go ahead and we can assign a horizontal well type geometry, a multi-kickoff well type geometry, an S-shaped geometry, and so on and so forth. And each type of geometry would require a different number of target points. So we're going to go ahead and create a couple of different types of well geometries here. Let's start with a horizontal. So we're going to go ahead, select the horizontal radio button. And for horizontal geometry, we need at least 2 target points. So you can go ahead and add the target point manually by clicking on this Add button on the right, or you can go to the second option here, Add from Map, and you can add target points directly from the GeoAtlas map. So if we click on Add from Map and open up the GeoAtlas window, we'll notice that the well has been highlighted automatically in the GeoAtlas map. So we can create some target points here. If you notice that the TBDSS field is actually blank because the target surface hasn't been selected yet, so if we click on the drop-down menu here, that field will be populated, and subsequently the TBDSS field will also be populated. We can go ahead and pick more than one target point, so we go on the bottom left box which says pick target point. We click on that box and go back to select more points. So as you notice that the cursor has actually changed into this crosshair symbol, which means that it is actively picking up target points now. So we're going to go ahead and choose one more point there for picking up our target surface. And once you're done, click on the Add button on the bottom right and click OK here. Alright, so our 2 additional target points for the well, for the horizontal well type have been added. I'm going to go ahead to the Calculate tab to view the trajectory of the well, since it looks a little off, so we can definitely always edit it accordingly. Okay. Moving back to the multi-kickoff trajectory type, changing the well type so we'll lose the correct parameters. Okay, click yes. Alright, so over here we would need one more target point. We're going to use the Add from Map option here too. We'll add one more target point right here, choosing Red Travel as the surface, and add. We'll click no there, and okay. Alright, if you notice here, we're getting a warning that Although the well path has been plotted, some parts of the well are not drillable, and we can see that why, because again, because of our approach DLS and lateral DLS settings, this might happen. We can, however, at this point go ahead and simply shift our target points a little to get rid of that. Okay. One last. Okay, so one last geometry type that we like to try over here is the S-shaped geometry. If you click calculate here, then the well path has perfectly been generated. One more thing that we can do over here is if you go back to the edit tab, we also have an option for creating something called an extended plan for an existing plan. So let's say that I have an S-shaped plan and I'm creating an extended plan. For the S-shaped plan. So I'm going to go ahead and choose the extension type as horizontal, and again adding from the map, adding one more target surface point before we move on. And here, if we click on the calculate tab, we'll be able to view the wellbore path, and we can see that the trajectory for this particular bore is a little complex because this is a combination of more than one extensions, right? So this way you can create a complex wellbore trajectory within GVERSE and you can add more than one extensions in there too. If we go ahead and we can use the save in well-base option here to save this well to well-base. We're going to right. Okay. If we go to well-base then, and the survey tab, we'll be able to view the borehole as an initially S-shaped well that ended up in a horizontal trajectory. Alright, so that would sum up this webinar right here. Thank you for joining in today. Good day.